You're in the extending Java APIs over the web with HTML5 WebSocket, just to make sure you're in the right room. This is not intro to PHP or anything like that. Seeing if you're still awake. My name is Frank Greco. I'm Director of Technology for Kazing. I'm here with my colleague Peter Moskowitz. And just a brief description of Kazing. Our expertise is in high-performance web computing, and you're going to see a couple of eye-popping demos to prove that we are experts in that field. And just a quick indulgence in ourselves. That's me. Anybody from the New York JavaSig here? Oh, bummer. I thought at least be one person beside myself. We're we're outside of Brazil. We're the biggest one. The Brazil guys kick our ass. I mean, they have 50,000 members. We only have 7,500 members. And also, I'm Director of Technology for Kazing Corporation. Let me introduce my colleague, Peter.
Thank you, Frank. Hi, everyone. I'm Peter, and I'm Kazing's developer evangelist. And one of my passions is to make invisible things that are covered deep under various layers visible, and visualize it and show what it can do for you. So in this session, one of our objectives is to do just that. And we also wanted to give you some ideas how you can extend the reach of your enterprise messaging all the way to the web. So we are going to get there as we build up the presentation. So first I wanted to show a quick demo how we can visualize this web messaging and web communication platform. So what you see here is a public URL on demo.kazing.com/racer. This is something you can try from home. This is rendered in a browser using WebGL without any plugins whatsoever. It's quite impressive. Only 15 or 20 years ago, we used to render these realistic images frame by frame, and it took minutes, if not dozens of minutes, to render each frame, and now we get these very pretty images. But this is not what we do. What we are doing is the real-time communication over the web. So you can control this car using the keyboard. You can turn the wheel, you can move it forward, you can drive it around as you would expect. So when we saw this demo, we figured that maybe this would be a good way to demonstrate what you can do with the real-time web. So what you can do is you can take your phone, and this is what I'm going to do right now. On the bottom of the screen, there is an ID that I'm going to use to connect to this screen. And all I have running on my phone is a browser, the out-of-the-box default Safari browser on my iPhone. And if the demo gods are nice to us, then we will be able to connect. And what I'm doing right now is I'm tilting my phone here. And with the tilt of the phone, I'm driving the car. So if you're interested how you can build something like this and how this works behind the under the covers, then you are at the right session. Just to give you a very quick, we can switch back, a very quick idea what's happening here. We have a browser running here on this screen, and I have a browser running here on my phone. And as I'm tilting my phone, I'm detecting the tilt information on the phone using JavaScript APIs, HTML5 APIs. And as often as I can, I'm sending messages to a special server, a WebSocket server. We call it a gateway, that in turn sends the message back to our desktop or to our laptop that is sitting here. And just so you know, the server is running on the East Coast in New Jersey, and we were driving it from here. So basically, our messages were traveling across the continent back and forth twice. It went there once, and it came back once. So this is the technology that we are going to talk about. First, we'll have a very quick review of HTML5. I would think that most of us have a pretty good understanding what HTML5 is, so it's going to take only a few seconds. We will talk a little bit about the communication means that are available to us in this new world, and then we'll move on to the actual APIs. And after discussing the APIs, it's going to be very important and interesting to see how the architecture of the applications that we can build as this new world is changing or is possibly changing, and what are the things that you need to look out for. And then we move on and talk about how you can layer extra capabilities, extra APIs and protocols on top of this very nice communication, the WebSockets. And then in the last third of the presentation, I'm going to show a handful of additional examples, more enterprisey examples that highlight what the technology is capable of doing. So, what is HTML5? HTML5 is an umbrella term. The main objective of HTML5 is to create a platform in the browser that allows us to build and run desktop-like applications. We have always wanted to build rich applications, and HTML5 has set this goal without using any kinds of plugins. In the past, anytime you wanted to build something rich, you probably had to use Flash, or you had to use Silverlight, or if you were a true Java person, then you had to use Applet or JavaFX. So now, with HTML5, there's a lot more that we can hopefully do, and we are going to see a few examples for that. In order to achieve this, HTML5 addresses a number of areas of the browser-based world, ranging all the way from video and audio through two-dimensional, three-dimensional graphics, offline storage, and connectivity. So every one of these can be, all of these topics can fill libraries by themselves. The one that we are focusing on in this talk is in the bottom right. It's connectivity. When we talk of HTML5, one of the challenges that we often face is it's new, it's modern, but how about the rest of the internets that's out there? How do you support old browsers? How do you support old mobile browsers? And so on. So the good news is, on one hand, that browsers are racing to support the latest and the greatest of the standard. So if you take a look at pretty much any of the modern browsers, all of the production ones, they do have very good support for many, many aspects of HTML5. What is the situation with older browsers? What is the situation with mobile browsers? Well, it goes feature by feature and functionality by functionality. Kazing, the company we work for, has put a lot of IP and a lot of emphasis on making sure that the connectivity aspect, if you're using our product, the connectivity aspect is working seamlessly. And connectivity is not simply a matter of whether the browser has native support for a given functionality. And here I'm primarily talking about WebSockets, but it also boils down to things like network connectivity. If you are accessing your application through a mobile device, you are going through very different kinds of network intermediaries than when you access your application from home or from your office. There are different kinds of firewalls and routers and proxies in the way that can affect this communication. So this is a very important topic because most of the things tend to work in a lab environment, but once you get out in production, then it can be a very challenging world. So a couple of words in a nutshell about the HTML5 connectivity features. In the world of HTML5, before HTML5, we have primarily been using HTTP. HTTP being a request-response-based protocol. All it does is it allows the user to click on a link in the browser or submit a URL in the browser, send a request to the server, and the server is going to send a response to that. There are a lot of improvements for HTTP. Speedy is just one of the examples where it reduces the amount of overhead. It forces you to use SSL, and it becomes a way more efficient way of implementing request-response kinds of applications. However, the fundamental real change in HTML5, definitely from a communications perspective, what we believe in general is actually WebSockets. So what WebSockets provide you is a full duplex permanent connection between your browser and a server component. We like to call it a WebSocket gateway, others call it a WebSocket server. And by having this full duplex connectivity between your browser and the server, you don't have to worry about building up that connection all the time. It's just there for you that you can use for two-way communication. So Your browser can always send messages to the server, and your server can always send messages to the browser. If you think of HTTP, it has always been a request-response, half-duplex, and asymmetric communication, where it's always the browser that has to initiate it, and then the server sends a response to that. There are additional communication techniques and security improvements in HTML5. Cross-origin resource sharing allows you to use resources from different kinds of domains in your applications. Cross-document messaging allows you, if your document is built up of multiple frames, that these frames can nicely talk to each other. Server-sent events support the notion of sending data pretty efficiently from the server side to the browser. The one we are focusing on is WebSockets. So what is WebSocket all about, and what is it really? It's actually two things. It has two main natures. One of them is an API. So if you are a developer, that's what you are really interested in. It is a set of APIs that allow you to build these message-oriented applications. The other dimension of WebSockets is a communication protocol controlled by IETF. So IETF handles the bits and bytes, the protocol that is going on the wire, and W3C is responsible for the API. The RFC was accepted end of last year in December 2011, and you can build these WebSocket-enabled applications, web applications, very quickly and very easily. What is very important is that WebSocket is trying to address the problems or the workarounds that we have been trying to come up with in the world of HTTP. So probably many of you are familiar with the notion of polling and Comet and AJAX technologies. The need has always been there to provide the richness and the responsiveness in the applications, but the only tool we had was HTTP. And now finally the industry has come together to support a new open standard that allows us to do just that in a way more efficient manner. And we are going to talk a little bit more about it. Now, the term WebSocket itself is a very nice term. We really like it, partly because we contributed a very significant part to the standard, partly because actually we claim credit for the first 3 letters of the name. Web in a WebSocket indicates that it is a web-friendly communication. That means that it starts its life as an HTTP connection, and then, and we are going to talk a little more about it as we go on in the talk, then we upgrade the communication to a new protocol, to WebSocket. Also, we are using the standard out-of-the-box HTTP and HTTPS port numbers, port 80 and port 443. That helps WebSockets to be conform to the already existing web standards. And we strongly believe that this is the most powerful and the most important API in HTML5 in general. So, now that we have WebSockets, what can we do with it? Why is it important to us? So let's take a very quick look at how the architecture is changing and how the architecture evolved. Back in the client-server world, we didn't quite like the idea of deploying applications to every individual thick client. So we came up with the web. One of the main inventions of the web was the web browser. The browser allowing us to render HTML documents to the user and allow the user to click around and enter URLs. So in this world of web, we have this half-duplex communication that is served up by a web server sitting up there in the web tier. Originally, the web was designed for static documents in academia, but very quickly we realized that we wanted to make it dynamic. So the way to make it dynamic is that instead of serving up static HTML files from the web server, we put some sort of an application logic there. Application server middleware that is responsible for generating the markup on the fly based on the request, based on the user's identity, time zone, and so on, and then return that to the browser. So you can see there is a full duplex connectivity between your middleware and your backend server, but you only have a half duplex connectivity between your browser and your application server. So what this means is that you, on the application server node, are generating a dumbed-down view, a dumbed-down UI of your application that you can get across, and you also have this limitation of the half-duplex nature. How does it change in the world of WebSockets? So as I mentioned, WebSocket is a connectivity between your client and a WebSocket server. So those clients can be mobile or desktop clients. And by having a full duplex connectivity between your clients and the WebSocket gateway, you basically have an end-to-end full duplex connectivity. But this is just one aspect of the story. Probably an even more important and interesting aspect of the story is that in the upper diagram, your actual application is running on the middleware, on the application server node. So as your user population is growing, you need to scale that out. And you are not using the power of the browser because the browser is assumed to be dumb. In this world, with the evolution of the capabilities that I mentioned in the HTML5 world, the capabilities of the browser become really powerful. Now you have the ability to run your applications on the browser, and you can use a full duplex connectivity between your browser and your backend using WebSockets. So that means that from the web tier, the application is actually moving to the browser, and you are using a very simple and high throughput gateway here to get the communication done. And this also allows you to scale out way better, simply because it's not your responsibility to run the app, but you can run it over on the browser side. So the app is moving from here to over there. If you think of the race car, that's exactly what was happening. We had the race car running in the browser, and then it was getting messages that indicated how it should do, and then it knew what to do. It was not that it got like static HTML rendered somewhere in the middle tier and then downloaded every time. It was an app running there. So we are moving from this document-centric kind of setting more to an app-centric world. So I think this is one thing to think about, and now I hand it over to Frank.
Thanks, Peter. Hope we're not getting anybody dizzy by doing this. So what can you do with WebSocket? And it's kind of a funny thing to say that, because what can't you do with WebSocket? Like if I go to you and you're working in an enterprise and I give you a socket, you can basically do anything, right? So here's a hypothetical thing. So I'm your manager, and I tell you that you have to write this really high-performance application for our group or for our company. And you have the choice of using a socket or using a raw socket or using HTTP. Which one would you use? Socket, right? So now on the web, you have the alternative of using HTTP like you've been doing for the past 17 years, or you now have socket behavior. Which one would you use? It's pretty obvious what you'd use, right? So, and we saw some of the interesting things from our friends at Oracle yesterday morning at the keynote. Arun showed the WebSocket, what was it called, Project Easel from NetBeans, which is very, very cool. And the ability to add WebSocket behavior to POJOs is a very, very cool thing. But the point about this slide is that you can do anything with WebSocket. That's the point. Don't think of this as like another Comet. This is not, 2000. This is not .com, and this is a push technology. Just think about, I can do anything I want. It's a bidirectional, secure, fat pipe over the web. So there's a lot of cool things that you can build. So the API is trivially easy. And here, we'll look at the W3C formal standard for the API. There's 3 callbacks. There's 5 methods. There's 3 callbacks and 2 other methods I can show you. On open, on message, on close are the callbacks. There's the instantiation of WebSocket. This is, of course, it's used JavaScript. A common mistake is that you try to use the WebSocket right after you say new WebSocket, and notice there's an on open that you should wait for. So that's a common mistake when you're doing WebSocket programming. Remember, now you're going over the web. It's not, the latency from creating a socket and a WebSocket is a little different, so you have to make sure you have the WebSocket connection before you go forward. Okay. And of course, there's send and close like you would expect. So the API is very easy. It's deceptively easy, right? If we can go back in the history books and we look at TCP from late 60s, early 70s, TCP was very easy. It looked like, wow, we'll just program in TCP for the rest of our lives, right? How did that work out? Who programs in TCP anymore, low-level TCP, right? We want to extrapolate, go up the ladder and use higher-level abstractions. We want to use our friendly APIs that we've been known over the past like 30, 40 years. And that was the only API that we had. As Peter pointed out, there's the protocol, right? The bits and bytes over the wire, and then there's the API, right? There's the IETF guys, and then there's the W3C. So the first implementation of the protocol, obviously it's a protocol. You could implement other interfaces to the protocol, as many as you want. The first one was JavaScript, because here comes the HTML5 train, and we know that the HTML5 train is a very powerful, fast-moving train. Just a little anecdote. Last year, there was one talk on HTML5. This year, there were 27, and with most of them talking about WebSocket, so you can see the acceleration and interest in this technology. Now, thankfully, we have an upcoming standard with API, okay, JSR 356. So this is a very interesting JSR to follow. You guys, it's not quite ratified yet, but you should just follow this guy. It gives us a formal API for Java, which obviously will follow the W3C suggestions. The other JSR to follow is the JMS 2.0 spec, which is JSR 343, if memory serves. So just be aware of that one. So how does this all work? As Peter pointed out, one of the contributions of Kazing to this technology was making this web-friendly. Okay, and the first connection that you make to a WebSocket-capable server is through HTTP. And part of the HTTP 1.1 specification was to ask to upgrade to another protocol. Right? So here's a client, it goes to the server and says, hey, do you have WebSocket? If you do, let me know. So our product does, Glassfish does, other servers do. Said, yeah, I got a WebSocket, I'm going to upgrade you and give you the handshake back. At that point, HTTP drops out of the way. So now you have a fat pipe. You effectively have a socket. So, I mean, since we're all techs here, there's WebSockets on top of TCP. HTTP was on TCP. Let me say that more correctly. WebSocket on top of TCP and HTTP on top of TCP. Right? We're all aware that how that stack works. Okay. And the overhead to doing WebSocket is very minimal. If you do a lot of web programming, you know that there's a lot of overhead with HTTP, especially for small payloads. Right? The metadata is phenomenally large. And if you're building an application, and HTML5 is all about applications. It's the changing, we're at the start of the next phase of the web, right? It's changing from a document-centric thing where we're trying to tweak it to make it do real cool things, and we're still tweaking, right? HTML5 is now changing the web into a programmatic framework. We're at the start of that cycle. So this is a really, really cool time, very exciting time. So with HTTP, there's a lot of this metadata stuff. You know, this could be overhead of 1,000 bytes to 1 byte, right? The overhead is phenomenal. But now the overhead is down to between 0 and 6 bytes. Effectively negligible, right? So it's a huge, huge difference. And if you're building things like trading systems, this becomes very important. Did I skip a slide here? Nope. So what we want to do is that we want to take, this is similar to the slide we showed before, we want to take some sort of Java service in the back end, the TCP. It doesn't have to be JMS, it could be any Java service. And we want to make it web-friendly. So we want to take things like JMS, since it's a very popular API, things like AMQP, XMPP, FTP, all these other nice protocols that we've known for the past 40 years, and make them web-friendly. Okay, we don't want to take some data, change it using some API, convert it inside the app server, and then munge it and send it over. We want to avoid that, right, because it's a lot of overhead. So what we want to do is we want to convert the low-level protocol, the TCP socket, into WebSocket and give you the familiar API on the endpoint. So wouldn't it be cool if you had the JMS API in JavaScript dealing with the back end? Isn't that cool, right? And we'll show you examples. So in case you've been living under a rock for the past 13 years, JMS is a pub/sub API. It's not a protocol, it's an API. I was there during the battles of making it a protocol and never worked out, so it was just an API. It's just that you subscribe interest into an object, and it's typically a string, and then when data gets sent out associated with that object, typically a string, you get the message. You guys know what that is, right? So it's very, very easy to do JMS. Hopefully JMS 2.0 will upgrade JMS so it's more modern, but this is basically how you do pub sub. So how does that now apply to what we do? Okay, so it's certainly a very, very popular API and I was about to say protocol, but it's not a protocol, API. And what we want to do is we want to take JMS TCP on the right-hand side, some Java internal enterprise service that you have. It could be market data, it could be notifications, it could be something. And we want to somehow convert it so now it's web-friendly and it goes over into a browser, right? Now, up until recently, we'd say like we have to do something with a plugin, right? Maybe an applet. But now, as of this conference, and Oracle themselves have said, we're moving away from Java in the browser, right? And that was stated very, very clearly yesterday. Moving away from Java. Matter of fact, everybody's moving away from plugins in their browser, right? That's part of HTML5 is no plugins. And what's the reason for that? Well, reducing the number of vectors coming into the browser, because there's a lot of security. I mean, you have to deal with like security 4 or 5 times because there's different vectors coming in. Well, get rid of them. We'll just have, the web. That's one of the driving reasons. Okay, so what we want to do is that we want to take JMS from the inside of the enterprise and make it go over the web. And this is really cool. That means that inside you can offer JMS through an application or through an API to your customers and users. So you can offer an API to your customers to build applications that use your service, cloud services. This is a very, very powerful concept. So our goal in what we do is make that middle part disappear, make it transparent, so that all you're thinking about is, in this example, is JMS or whatever the protocol is. It could be AMQP or chat XMPP. Just think about the application. That's what you want to do. Like, who thinks of TCP anymore in your program? You don't do that anymore, right? We haven't done that in 40 years. We're doing the same thing in WebSocket. WebSocket is TCP for the web. Okay, so we want to make the entire middle disappear. So let me turn it back over to Peter, go over some code examples.
So what you see here, does the mic work? Okay, so what you see here is 6 simple steps how to get started with a JMS-based application. First, you need to create a connection. This is a JMS-based application running on top of WebSockets. So first you create a connection. The connection can either be unencrypted WebSocket connection, and you see the protocol is WS, or it can be a WebSocket over SSL, over TLS, then it's a WSS, WebSocket Secure. Then you have the ability to create a session. You can see the API down here. Here you can specify properties like whether you want to make your transaction, your session transacted or not. And then you have the ability to create JMS objects, things like topics and queues. JMS topic provides a one-to-many kind of communication. Queues allow you one-to-one communication. So in our case, we are going to take a look at a quick example after this. We are going to create a topic, and then you can start sending messages into that topic. You can think of this topic as a pipe, like as a physical pipe. You put stuff in on one end, and on the other end it comes out, and you can it can distribute it to multiple readers. On the consumer side, you need to create the consumers who are going to take the messages, read these messages, and then in the world of JavaScript, you have the requirement to create message listeners. These are the functions that get invoked when, for example, a message is coming in, or when an error happens, or when a connection closes. These are the special events that are invoked. And a very important thing from a development perspective is that this is an event-driven environment, an event-driven architecture. If you think of HTTP polling, very often what you have to do is you have to send a request to see if there is anything on the server for you. and you never know if there is something there for you, so you get back most of the time, oh, there is nothing there for me. Every now and then you do get back some information that, yes, there is something useful for you. Here in this world, you are getting messages, and whenever there's a message for you, you get notified. There is a function that gets invoked, and then you can react to that. So it's a very nice, nice model and very nice paradigm. And then, after you have established your connection with the producers and the consumers, you can start sending messages. So here in the first code sample, we show how you can set message properties. This is basically header information in JMS. So in our case, we are setting a string property as part of this JMS message, and then we send the message. And then here is the listener, the message listener, the function that gets invoked when a message is coming in. So if you think of the race car, I'm a message producer with my phone. I'm sending messages. Every time I am tilting the phone, the send function is invoked. And on the car, every time there is a message coming in for me, then the handle topic message is the function that gets invoked in this example. So I get notified that, hey, I need to turn the wheels to left or to right. So it's very, very straightforward. So let me show you a couple of examples, and now I'd like to switch to the other microphone, the attached one. Thank you. So we put together a very simple tutorial. The tutorial, you can check it out, is on tutorial.kazing.com. And what the tutorial shows is a set of code samples that we built in a tool called JSFiddle. JSFiddle is a very nice browser-based JavaScript editing environment that allows you to specify your HTML code, your JavaScript code, your CSS here in the top right, and then the rendered code is down here in the corner. So what we are doing is we have a slider here in the top, and we can start, let me reload this page, we can start interacting with the image. And as you can see, as I'm moving the slider, the image changes. But what is more important is that here in the logs, you can see that every time there's a change in the image size, in the slider position, we send a message out there. Where do we send it? Well, we send it on a JMS topic, so anybody who's interested in it can listen to that. So let's just give that a try. I'm going to start a new browser with the same URL. And here I have the same code. So I start changing the, move the slider in one browser, and you can see the other one nicely receives it and resizes accordingly. Let me go over here, and if I can adjust these guys, then you can see it's working nicely. So what we have done here is an interesting paradigm. You can send messages from a browser to the server. You can send messages from the server to the client, and then you can come up with all sorts of combinations. So the combination that we came up with here is a kind of a reflector pattern. I'm sending a message from one browser to the server, and then it publishes it back to all the interested subscribers. So if I had 3, 4, 5 browsers, all of them would be nicely animating here. So we have implemented a very simple, using JMS, a very simple peer-to-peer kind of communication pattern. All the code, the entire application code is running here in the browser. The only thing we use from the server side is that it supports JMS. That it's JMS. We have basically a topic, and looks like somebody has joined in. So with JMS, you can send messages and receive messages, and then you can actually. So you can go ahead, and on the iPad, you can start moving the slider, or just, if you can. It's a little tricky to get. Yeah, there you go. You are moving the slider. Very cool. Very nice. Excellent. Okay. So if you are interested, you can go to tutorial.kazing.com, and there is a series of blog posts that explain what it takes to build an application like this, and every step is documented in JSFiddle with a code sample sitting there. So it's very straightforward to follow, and I encourage you to take a look at that. Okay, Let me show you another demonstration, and I'm going to show you a recording of this. What you see here is my laptop on the left-hand side with the browser open, and on the right-hand side you see my iPad. And in the iPad, I'm starting a browser, and I'm pointing the browser to the same URL that was invoked over on the left-hand side. And these are images coming from Flickr. These are the 10 most popular images of the day. And I'm interacting on one device, moving the images around, and through WebSockets, the other one is following it. So you can see how they are mirroring. So this is yet another example, kind of a similar pattern, but another example for something like collaboration, like real-time collaboration capabilities, where I'm working in one corner of this screen, and you are working in the other. You see multi-touch here. And then here I move over to the left-hand side, and I use my laptop's mouse or touch screen to make to resize the images. And the icing on the cake is that with one hand, I'm controlling the laptop. With the other hand, I'm controlling the iPad. And you see the full duplex nature of this, right? So if you have ever used Google Docs where two people or multiple people are editing the same document, this is kind of similar from a functionality perspective, probably a little more visual than that. Yes?
What's your ratio of?
It really depends. So basically, we are relying on the underlying connectivity. So when we use the race car, the server is running on the East Coast. We get 10 to 12 messages per second. So there's quite a bit of latency there. What I used here in this demonstration, I was running a gateway on my machine. I created a shared network. Basically, I created my own Wi-Fi network. That's what the iPad connected to, and then it was very, very smooth. I think it was close to 40, maybe even higher than that. Yes. On iPad? Yeah. So very good question. Not all browsers support WebSockets. The latest version of iOS and Safari do have native support for WebSockets. WebSockets had multiple versions and multiple releases. To be perfectly honest, I don't even know if Safari is on the very latest. I think on iOS 6 it probably is. On iOS 5 it was not on the latest. But thanks to the research and development that we put into our server, it's completely hidden from us. So I could have run this demo in IE6 simply because of the emulation that we put in place. It's completely hidden from me as a developer. So what you do as a developer, you write your code using the WebSocket API. You include a library, and that library does the heavy lifting. If there is no native WebSocket support there for you, then it uses clever emulation that comes very, very close in performance to the native WebSocket connectivity. We are going to do a Q&A at the end, so I take this last question. But
I was just wondering how you have to go to the convention.
So I did see some over our company Wi-Fi network, but when I created my own little network, there was no such problem here. So it really depends. Yes, I mean we are sitting on top of the TCP layer. So if there is if that layer is congested, then yes, you are seeing. So basically, you can't go faster than light, or you cannot go faster than what the physical connectivity allows. If that answers your question. Okay, let me show you another demonstration. How do I do this? So before, actually, no, I can start this and then explain. So given that we are at Java 1, we figured we wanted to do some Java code even in the browser. So what you see here is NetBeans 7.2, and we built a simple JavaFX app. Frank mentioned that one of the types of applications that many of our customers are building is trading kind of applications, where you have trading data available on a server, and then you want to get that very quickly and in a fair manner to all your clients. So out of curiosity, we wanted to see what it looks like in JavaFX. Now, in order to do that, you need Java APIs. So this is one of the things that we have done is we have built, in addition to the JavaScript APIs, we support Java, Flash, and Flex, Silverlight. So basically, I was using the Java APIs here, and this is what is going to get standardized with the new JSR that's coming out. And you can see the data changing in the JavaFX app here on the right. On the left-hand side, we have a JavaScript application that uses the exact same data feed. So this is a nice example of going from different kinds of client applications against the same servers. So we have a kind of a fake or a demo stream that plays back or streams random trading info, and then you can access that from a Java client or from a JavaScript client. Okay. Wanted to show a last demo. If you go to demo.cousin.com/ Forex. So this is a foreign exchange demonstration. What you see here is large amount of data coming in here. Here you can go 20 messages per second, 50 messages per second, or 100 messages per second. This is not something that you can do with in a scalable fashion with other technologies. And then you can take these currency pairs, and then you can drop them here, and they will pick up the data. So it just shows the performance and the rate that you can achieve. And again, there is no trick. This is an out-of-the-box Chrome running here, and you can get the same experience at home when you go home and go to the Cousin demo site on demo.cousin.com, and you can try it out for yourself. Okay, so last but not least, I wanted to talk a little bit about the presentation tool that we are using here. Press the wrong button? Oh, yes, actually it's 2. Nope, 3. So you probably noticed that we're doing these fancy animations, not only because we like these fancy animations, but because we wanted to show something with this. Anybody who knows Prezi as a presentation tool? Okay. So those of you who don't know, Prezi is a very cool tool. It gives you an endless two-dimensional canvas. You put your objects on it, you can rotate them, and the way you go through your presentation is that you move an imaginary camera over the various objects. You zoom in, you zoom out, and it's very nice and very cool. And somebody built an open source version of this in JavaScript. So what you see here is based on this library that's called Impress.js, and it's all very nice. And when we saw this, just like with the race car, we went like, okay, maybe we can do some interesting things with this. So here I have my iPad. And what the iPad is doing, it's connecting to the exact, so basically here I'm in a maximized Chrome running. And the iPad is connecting to the same URL and connects to the same presentation. So when I am navigating on my machine, I'm doing a previous slide or next slide, the iPad is nicely following it. So what's happening is I have an app written in HTML and JavaScript and CSS that's running on my laptop, and the exact same app is running here as well. And they are just sending messages through the WebSocket server to each other. Again, another example for peer-to-peer communication. And you can take this to the next level. I was always envious, I've always been envious about people who had remote controls. And I was like, that's not fair that we cannot have a remote control. So I'm starting up Safari on my phone, and I'm connecting to the presentation. Here in the top left, you see a presentation ID. So I'm connecting to this URL. And if you have an iPad, you can give it a try as well. I have a URL for the remote control functionality that I connected my phone to. So now I'm using my phone to advance the slides, go back and forth. So what is actually happening is, actually I think we have a slide about that. Yes. So what's happening is I have a presenter machine. The presenter machine is the laptop that's here on the podium. And every time I press on the arrow keys, it sends a next or a previous message. And then anybody who is interested in that, typically the clients, maybe your iPads that you have here or my iPad over here, the grays over on this side, are receiving the messages, next and previous. Obviously, beforehand, you should have basically the same application downloaded. And then the next and previous message drives not only my presentation, but your presentation as well. And then I took my phone. Phone is on the bottom left corner as a remote. And I'm sending next and previous messages. And the only one who is subscribed to that is the presenter machine. So the presenter machine is subscribed to the remote control messages, next and previous. And then, on my behalf, sends it out to all the other clients. So it's again, a very, very different kind of application than your regular banking app or your regular library application, right? In those applications, those apps actually are running on an app server. They're generating dynamic HTML, and they give you the markup. They give you the HTML, and your browser is stupid. Here in these cases, the browser is smart. The browser runs actual code, HTML and first primarily JavaScript, and is capable of listening messages, sending messages, and that influences and affects what it does. So we are actually running true apps here. And when you remember, if you remember the slide that Frank showed you, a couple of slides back here, what you see here is there is this full duplex connection and communication between your clients and your back end. So if you kind of think after this, this resembles much more a client-server world than a three-tier or a multi-tier architecture. We are at a point where we have the same power as we had in a client-server world. So that's very, very powerful and very capable. Okay. So this concludes the demos, and I'll hand it back to Frank.
Thanks, Peter. I think we have a few minutes left. So as someone pointed out, what about older browsers that don't understand WebSocket? And what about intermediate proxies, single sign-on, all the enterprise stuff? And certainly that's a very interesting discussion. And as a company, we can have that discussion with you, but this is not the appropriate forum. This is a technical conference. So if you're interested, you can contact us offline to get the additional information. But all the enterprise features is something that Kazing has added to the standards. So what are the next steps? And as you can see, this is not your father's Comet, right? This is next generation stuff. This is very, very powerful stuff. This is an inflection point in the web. This is really, really cool stuff. And what we've done is that we've given you back your APIs that you're familiar with. Because we've seen, WebSocket API. It seems very easy, just like the TCP API was very easy. So when you're back in school and you learn about distributed computing, you learn about socket. Wow, this is really cool, right? What do you learn the second day? Protocols. So you can't just use WebSocket by itself. It's difficult, right? You have 5 simple methods. It looks easy, but it's really not. You have to worry about out of order, packets coming in. You have to worry about the APIs, things like that. So what we're giving you is we're giving you back the familiar APIs, the JMS API, the XMPP API, the AMQP API, things that you all know and love. That's a big benefit. So think of what we have here as sort of like, butterfly flaps its wings. Like, it seems like a little thing has changed, but it really changes everything, completely changes everything. It gives you this really powerful feature that where you can build applications. And as we go forward into other areas, especially things like Internet of Things, which was mentioned yesterday during the keynote, when certainly where Java is moving towards. This is a very powerful tool to use in the Internet of Things world, and certainly now with cloud and mobile, it's very, very appropriate. So I think at this point we have 10 minutes for Q&A. So anybody have any questions? We'll start from the back this time. Are WebSockets affected by HTTP timeouts? Well, they're not HTTP. That's right. They're not HTTP. Right.
So just to elaborate on that, the way a WebSocket connection gets established is that there's the browser initiates the WebSocket connection, says I want to create a WebSocket connection, and then sends a request to the server. There's a special header in. We didn't go into all these details because we wanted to focus on how you can eventually use it. But there's a special header that indicates that I want to use WebSockets, and then the server has to accept that, has to say, okay, I'm happy to use WebSockets, so sends back an HTTP response, and that's where the HTTP part of the story ends. This is the web-friendly part of establishing a WebSocket connection, and then HTTP goes away. And then WebSockets comes into place, possibly on the same ports, port 80 or port 443. So HTTP is plays a little part basically plays a part in the establishment of the connection, but it's a different beast, as Frank said.
That's true, and perhaps some of the 356 might address some of that. So we're hoping to see where that takes us. Also, just in terms of security, the URI scheme is WS://. There's also WSS://, just like HTTPS for encrypted. And in production, all of our customers use WSS, not WS. It's just you got a question, sorry.
So it looks like, from a company firewall standpoint, right? The only port you've got to open up is the 40 and then everything will just work.
That's right.
It kind of follow up to that. So to use WebSocket, I need a browser probably, the server WebSocket. And then on the server side, can I just get Tomcat with WebSocket, or do I have to get your server?
Well, first you need a WebSocket capable client, right? Whether it's native, like all the modern browsers. Let's be fair. Other than IE, they all support it. But with older browsers, you need some sort of emulation technology, and that's what we provide as a product. So you can fall back to HTTP long polling. There's open source things you can use, but if you want high performance, we have a solution for that as a product.
On the server side, does nothing get to standard Java server, or does special server involved?
Well, there's various methods for it. We have a certain philosophy that we use, that we have a standalone Java process that connects to any TCP service. There might be another product that uses some other mechanism.
But it is a WebSocket server. You do need a WebSocket gateway that is capable of communicating with a WebSocket client.
Right. Remember.
Is this separate from a Java server like Tomcat? Separate server, next to Tomcat?
Our solution is separate. There are other solutions that might be part of the app server. Glassfish, I presume, is part of the app server. Just different implementations. Just the standard is on the API and the protocol.
You just look like a queue or a topic, right?
Pardon me?
You look like a queue or a topic from the client's standpoint.
Cure a topic.
A queue or a topic, a JMS.
Oh, you mean in terms of JMS? Yes, you're right. I'm sorry. Yes. You had a question.
Two things to ask. First, about performance. What is the performance when we came to a lot of clients, let's say 10,000 clients that active?
Mm-hmm.
And two, about the concurrency. How is the concurrency when we talk about two clients doing the same thing at the same millisecond? What will happen?
Well, in terms of scalability, so there's many implementations of WebSocket servers. We have ours. There's other open source product. Glassfish has it, right? So we're all competing for scalability. We believe we have the best, and we scale to many. We have in our lab, we can go up to 1 million connections. It's obviously all depending upon your network. If you have a fast network, we'll go fast. If you have a slow network, we're just going to go as slow as your network.
It really depends on the network. If we have good network, then
We sit on top of TCP, so we stand on the shoulders of the guys underneath us. So whatever, if you have a fast NIC and you have a fast driver, TCP driver, we're going to go blazingly fast.
the server is not to worry about. If we had a good network, then the server is okay.
You're an architect, right? We're all Java architects, right? So there's all different components into the puzzle, right? There's our gateway, the WebSocket gateway. There's a back-end service. There's the NIC. There's memory. So as an architect, you have to weigh all that. We provide you the best WebSocket server, obviously you have to consider the other components to the solution. Okay, how about this side?
There's a follow-up. So concurrency, that's up to your application. So basically you get the communication mechanisms, right? And then it's up to your application to handle those kind of things. So JMS has certain level of support, but then it's your application's responsibility. Let's say you have a higher level business object that cannot be manipulated by multiple people at the same time. You would have to take care of that.
Actually, just brings up an interesting point. So we get a question often, well, how reliable is WebSocket? Remember, WebSocket is at the low level, so reliability is added upon the additional protocols above that. For example, JMS has its notion of reliable transmission. You know, XMPP has its own. FTP has its own. So it's not that WebSocket's providing that. You know, it gives you, just like TCP does, the guarantee is sort of like it guarantees a connect. It's not guarantee of the functionality. So it's up to the protocol at this level to give you reliability. This gentleman over there. So part of the HTML5 communication standard, there's WebSocket, there's server-sent events, there's post message, there's something called cross-origin resource sharing, which basically allows you to go past the number of connections. And we, I don't want to get into a product pitch here, but we offer that in older browsers, so it gets you past that connection limit.
One more thing to add to that is that we have clustering as well, so we can scale out to pretty much any number of users using very sophisticated clustering. And these are the services that you get from an enterprise grade server versus from an open source project, right?
I have a question maybe low level, because we are talking about TCP and WebSocket. Just like WebSocket is over TCP, right? So we use TCP connection to kind of for the reliability, for the fault tolerance, but for connection, like guarantee.
Well,
To guarantee the connection. Because
TCP guarantees ordering. It's ordering, sort of not message delivery. Don't assume that TCP gives you message delivery guarantee.
Yeah.
Yeah, JMS does. Other protocols do.
Okay. High level.
Right, and that's what we offer. So I think we have time for one more question. There's a gentleman back there. That's you. Yeah.
So is there a standard built into the server side, or is there in our product how you sort of authenticate the user and match up the HTTP session with the WebSocket session, so you know who they are?
So what we offer is we're very standards oriented. So we offer the Jazz plugin in our product, the Jazz Authentication Authorization Service. So you can write your own login module that does authentication, and we also offer authorization. So if you want to track for JMS specifically, who can pub, who can sub, who can transact, blah, 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 blah. So we offer you the interfaces so you can implement that and plug it into our gateway.
So in the JavaScript code, do I have to, over the WebSocket, communicate who is this user?
So every company does that differently. Some people use cookies and send the cookies as part of the URL to the login module. And in the login module, you parse it and you do something with it. I can go into details how you do that, but yeah.
That's above what's built in.
We give you the interfaces, and it's up to you to implement that. Okay, thank you very much, guys. Have a good conference.